So, hello everyone, my name is Siddharth Yadav and I'm going to be presenting on the topic of database concurrency control. First, I would like to thank Mr. Varun Mathur and Mr. Jihyong Park for giving me this opportunity to speak on this topic. So, what is concurrency control, which is essential for managing simultaneous data access in multi-user environment. Concurrency control is crucial for maintaining data integrity, consistency, isolation, durability, commonly referred to as ACID properties. As we dive deeper, we will explore the mechanism, challenges, benefits, and real-world application, particularly focus on Amazon Prime. So um, we have the the fundamentals of concurrency control. That concurrency control ensures that multiple transactions can operate simultaneously without compromising data integrity. The ACID properties like atomicity, consistency, isolation, and the durability form the backbone of reliable database transaction. Concurrency control mechanism address issues like lost update, uncommitted data, inconsistent read by employing techniques such as locking, isolation level, transition, and control protocols. So the various concurrency control mechanism exist to handle concurrency transaction effectively. Log-based control uses log to prevent conflicts, but can lead to deadlocks and performance bottleneck. Timestamp-based control order transaction to minimize conflict, while optimistic control checks for conflict at the end of assuming that they are rare. Two-phase locking where transaction uh, uh, and release which acquire and release lock in two phases is also widely used. Each mechanism has its strength and trade-off in balancing data consistency and performance. As you can see, there is a lock. For example, when this person is two person orders the same item within the same Amazon app, and it's one side there is a lock that didn't allow the other person to order the same item within the field. So it after when the second person commits his transaction, then only he is committed is, and then the database table is updated, and then it's rolled back to the first person who is about to do the transaction. So some of the key findings and some of the challenges that is faced today is like implementing the concurrency control prevents several challenges like deadlock, lost update, inconsistency reads, and performance overhead are common issues. Solutions include deadlock detection resolution mechanism using isolation level to control data visibility and optimizing concurrency control algorithm. Striking the right balance between isolation and performance is critical, especially in high traffic environments like Amazon Prime. Efficient conflict resolution and maintaining system responsiveness are also essential for a robust database system. So, in recent advances in database, like concurrency control includes the in-memory database, distributed database, and the integration of machine learning in the memory significantly reduce access time but requires optimized concurrency strategies. Distributed database spread data across multiple nodes, introducing new challenges in synchronization and consistency. Machine learning can predict and optimize concurrency control decision, enhancing performance and reducing conflicts. These innovatives are crucial as we move towards more complex and scalable database architecture. So this is one of the examples that I have, like the lost update problem in the concurrency control, which occurs when two or more transactions modify the same data, resulting in an uh, update being overwritten or lost by another transaction. Like as you can see, the one person has given the transaction, but it has taken the first transaction, but it hasn't prevented the second one from having the transaction, so it is locked. So it in his computer it will be showing an update error. Then there is another example of dirty read problem as well, in which one transaction updates an item, but due to some unconditional events like the lock system event, and the transaction fails, but the transaction before rolling back in the second one has some transaction is read by the another person, like in let's say the third transaction, so it creates a very big problem. There are certain cases of Amazon Prime case study as well. So let's look at Amazon Prime as a case study. As a global streaming platform, Amazon Prime relies heavily on efficient concurrency control to manage real-time user interaction, personalized recommendation, and consistent data across devices. The benefit includes improved performance, scalability, data and consistency, and optimized resource utilization. However, challenges uh, such as concurrency control, overhead, maintaining consistency in a distributed environment, handling peak loads, need to be addressed to ensure a seamless user experience. So, in conclusion, database concurrency control is vital for maintaining data integrity and system performance in a simultaneous transaction. It involves a delicate balance between isolation and performance, especially in distributed system. Recent advances offer promising solutions to emerging challenges. Amazon Prime exemplifies a practical application of this concept, highlighting both the benefits and challenges of implementing effective concurrency control mechanism. So thank you for your attention. I look forward for any questions from you. Thank you.